HVAC temperature rise formula tells you airflow in cubic feet per minute by dividing heat input by 120 times the measured temperature rise, 2,200 print. Use it every time you test airflow to catch undersized ducts or poor blower performance. Measure supply and return temperatures with two matched, fast response probes placed close to the airstream without touching metal. Calculate temperature rise as supply minus return, then apply the formula. Airflow CFM equals heat input in British thermal units per hour, divided by 120 times temperature rise in degrees Fahrenheit. If you only have electrical heat input, multiply voltage times current times efficiency and convert to BTU per hour by multiplying by 341.2, while for gas heat, measure manifold pressure and use the appliance-rated input corrected for combustion efficiency. Always allow the system to run at steady state for at least 10 minutes after start and check that the blower speed and static pressure are stable. Note that blower motors with variable speed drives need their actual RPM verified because factory labels can be misleading. Compensate for long probe leads by zeroing both probes together in still air before each run to remove offset, and record ambient temperature and barometric pressure if you want accuracy to within 5% 2C. A small correction factor helps at high altitudes. Use matched calibration thermistors or thermocouples from the same batch. Log probe serial numbers with each test, and rotate probes between supply and return occasionally to detect probe-to-probe bias. When measuring systems with short duct runs or horizontally mounted coils, take multiple readings across the grille and average them to avoid false low temperature rise from stratification. If you suspect sensor drift, perform a 2-point calibration against an ice bath and a warm bath or a certified reference meter. Document calibration dates and tolerance limits so you can prove traceability for warranties or code inspections. One of the top 3 common mistakes is relying on an uncalibrated temperature meter, which produces sensor drift and error. Fix this by zeroing both probes before each test, performing periodic 2-point calibrations, and swapping probes to detect bias. One of the top 3 is using probes that touch metal or are placed in dead zones, causing false low or high temperature rise and incorrect airflow. CFM fix this by suspending probes in midstream with non-conductive mounts, taking multiple grill samples, and ensuring probes do not contact metal. One of the top 3 is ignoring steady-state conditions or variable speed blower behavior, leading to inconsistent readings. Fix this by running the system until temperature and static pressure stabilize, verifying blower speed with a tachometer, and recording conditions so repeats are comparable. BigHomeProjects.com lists trusted HVAC contractors and test and balance specialists who understand temperature rise testing and probe calibration, making it easier for homeowners to find certified pros. The directory helps contractors get work by showcasing services, reviews, and contact details so they connect with local clients needing accurate airflow CFM measurements and calibration services.